We've talked about this before, is what do we call a transformation that's a multiplication that's out in front of the function? And what did we talk when it's inside that function and it's a multiplication? Inside the function. That's a horizontal stretch or compression. And we've talked before, if you're adding a number inside the function, that is a. And if we're adding it outside, it is a. All I'm going to do is just change the vocabulary a bit. The A, yes, it's the vertical stretch or compression. But it's actually the amplitude, which is a word we looked at yesterday. It's the height of the graph. Yes, B is the horizontal stretch or compression. It's kind of the period. It's related to the period, but not quite the period. The B value equals 2 pi divided by the period. B equals 2 pi divided by the period. Why would it be T? Only when you're doing with time, but we won't always be dealing with time. I know. And I can actually switch. Sorry. Because that's always time, right? Because you're always doing it with time. We don't. Yeah. I'm going to switch these so we can have a second formula that says P is equal to 2 pi divided by B. Andrew, did you have a question?
Yeah. Would it work if it was 360 divided by whatever?
Yes, but our default is always radians unless the question says otherwise.
I don't know if it should. Last time she did like it. So yeah.
Maybe she brought you a cookie this time.
Did she? No. She has nothing in her hands.
2 pi divided by B. I just switched the P and the B. We're going to use these two formulas interchangeably. Yes, the C is the horizontal translation, but I'm going to get fancy schmancy on you. I'm going to call it the phase shift. The phase shift. Shift means translation. Phase comes from the phases of the moon or phases of the sun. The phase shift. And yes, D is the vertical translation, but we're going to call it the center line. And I'll tell you what that means in a second.
Question?
Yes?
Why can't you leave them the same?
Because scientists came and said, no, we're going to call these different things. And mathematicians are like, grr, scientists, why do you confuse stuff? And the scientists are like, be quiet, we make more money. And we're like, okay.
And besides,
That's really-
scientists is
Yeah. Yeah. Science does the why, we just tell them how to do it. We're kind of little peons in the science world, actually. A little bit. So what this allows us to do is actually just look at the equation, and we can identify the amplitude, the period, which should have a comma after it, the phase shift, and the center line. A standing for amplitude is the easiest. It's what's ever in front of the function. If it's negative, you take the absolute value. Why do we take the absolute value? Because it's a distance. It's the height of the graph, and a distance can't be negative. So it's whatever number's in front. It's whatever that vertical stretch would have been. So the amplitude is 3. I'll come back and do the other ones. I'm going to do all the amplitudes first. For B, it's whatever's in front. If it's negative, we take the absolute value because the distance can't be negative. So we would say the amplitude is 2. The last one, there's no number in front. Oh, but yes, there is. It's a 1. Okay, so to amplitude's the easiest. It's a number in front. Take the absolute value if it's negative. The period. Period is kind of the B value, but not quite the B value. It's 2 pi divided by that B value. B value is the number tucked between sine and the bracket, or sine and the x if there is one. So it would be the number tucked right in between here. We don't see one, but we know it's there. It's sine of 1x. So this would be 2 pi divided by 1, which gives us a period of
360 degrees.
Or 2 pi for the radian fanatics. And that's why yesterday we said the period, the length of a sine graph is 2 pi. That's where it comes from.
The radiant fanatics, that's probably everyone but me.
You're staying true to those degrees.
Yeah.
The second one, it's always 2 pi divided by the B value. The b-value is the number tucked between the function and the variable. In this case, it's a half. Just be careful when you're dividing by fractions. What do we need to do to that bottom fraction? We need to take the reciprocal, so this is going to be 2 pi times 2 over 1, which would be 4 pi. Which should make sense because we know that this 1/2 in there is a horizontal stretch. So what we've done is taken the normal period and stretched it out twice as far. That's why it's becoming 4 pi.
So for a degree fanatic such as myself, that would be 720, I'm guessing.
Yeah, I don't know, we just wouldn't do it in degrees. Yeah, I don't know.
Unless you're me.
Yeah, that's okay. The b-value is the guy tucked between the function and the variable. So this is going to be 2 pi divided by 2. So the period's going to be pi, which again should make sense because that's a horizontal compression. So we've taken the normal period and smushed it in half as far. So we're going from 2 pi to pi.
AK, or 360 to 180.
The phase shift is just the c value. So it's the number that you're adding inside the brackets with the variable. Do we have a phase shift in the first one? No, so we just say it's 0.
-0.
Do we have a phase shift in the second one? No, so we just say it's 0. Do we have a phase shift in the third one?
Yes.
And it's got that idea of the left goes positive and the right goes negative, so we say that it is -3. So it means it's 3 units to the left is what it's saying. Okay, so far nothing different, I'm just changing the vocabulary. The center line is the d-value. It's the number we're adding and subtracting outside the brackets at the end of the function. Do we have one of those values for a?
Yes. 4.
That means your graph is 4 units up. Do we have one for the second one? So we call it 0. That means the center of your graph is right on the x-axis. Do we have...
The center of this graph must be right on the origin.
You got it. Do we have a center line in the third one?
No.
So we call it 0. So this is the first skill you need to be able to do. Given a sinusoidal equation, tell me what's the amplitude, period, centerline, and phase shift. Now we're going to go backwards. Now I'm going to give you amplitude, phase shift, centerline, period, whatever I feel like, and you're going to give me an equation. Amplitude is the same as the a value. So it's telling you that a value out in front is going to be 3. The period is kind of the b value, but not quite the b value. What's the relationship between the two? Kind of. 2 pi divided by the value. So b we know is 2 pi divided by 2. So the number I'm going to end up putting into the equation is pi.
180.
Okay, so b is the one you need to do a little bit of work to get. Phase shift is the c value, and that's going to be 2. And I don't have a center line, so it tells you that d value in the equation is nothing. I'm not going to have to worry about it. Now I want to note that the question says a sinusoidal equation and not the sinusoidal equation, because you can get creative here. You can use cos or sine, it doesn't matter. You could have a negative amplitude, it doesn't matter. You can do a whole bunch of creative things here, and they're all going to be correct answers.
Do we have a -0 in there?
No, you know. Anyone else, yes, but you know. So we're going to start with y equals because it's an equation, so we need an equal sign and we need something on the other side. I'm going to put the a value first. If I wanted to make it negative, I could. I'm going to follow by cos or sine, completely your choice. I like sine better.
This is sinusoidal.
The b value comes next. He gets tucked in between the function and the variable. Because I have a c, I need to open a bracket. Variable comes first. Now, how do I make this a phase shift of +2? What am I going to do in the equation? -2, close the bracket. These have a million different answers because I could put -3 cos pi x minus 2 and it would still have these characteristics. Okay, so if the question has, or the answer has sine and you have cos, not a big deal. If it has cos and you have sine, not a big deal. If they put a negative, not a big deal. There's a million answers.
If it could either +0 or -0.
Yep, yep.
I'm doing that.
Amplitude of 4, again, that's our a value, the one that's in front. What you're going to want to do is just put pi in for b, but that's not true. We need to do a little bit of work. B is 2 pi divided by the value they give us for the period. 2 pi divided by pi is? Okay, so don't just assume you can stick that period into the function. There's a little bit of work for b. Do I have a c value? So it's 0. What the heck is a vertical shift?
Center line.
It's the same as the center line, so it's telling us d is -2. You have to start with something equals, it's usually y. You could use f of x equals, you could use g of x equals, but you have to have it equal to something. A comes first, which is 4. Sine or cos, your choice. I'm going to cos this one since I signed the last one. B comes next. Do I need to open a bracket?
No.
Why not?
No. Phase shift.
Do I need to use an x as my variable? No. What's my other variable that we sometimes use in sine equations? Theta. I'm going to throw theta in just for fun. And then what do I do with the d value? Just tuck it at the end, -2. That is a possible sinusoidal equation that has these characteristics. Again, you could have -4, you could have a sine, you could have an x, you could have an m, you could have a p, you could have a gamma, you could have whatever you want in there, and it's still a correct answer. How are you feeling so far? Okay. You could. Yeah, you absolutely could put brackets in here. We just get really lazy and we don't, but you could. Standard amplitude. What the heck does that mean? Yeah, that's just a equal to 1. That's our normal base cosine sine graph, so unit circle. B is not 2/3, and that's what your brain is going to want to do is just take that and make it the b value, but it's not. It's 2 pi divided by 2/3.
That's 2 pi times 3/2.
It definitely is 2 pi times 3/2. Offer of 3 pi, where did the 2's go? They're going to cancel because we're going to have 6 pi on 2 and then reduce it to 3 pi. Look at the difference between the period and the b value. Okay, you can't just stick the 2/3 into the equation for b. It doesn't work that way. Do we have a phase shift? So I don't care about c. Vertical shift means d equals 4. Write me a sinusoidal equation that has those characteristics. This was the most common answer on the exam last year. I know because I marked 800 of these questions. Okay, number 1, on the very left-hand side, I've lost a half mark. Why have I lost a half mark? Second half mark I lost is I have 2 variables, an x and a theta. And you're like, where did x come from? Where did it come from? What did I do there? What should I have written instead of the x? Pi. So that was a 1.5 mark off a 2 mark question. Most common answer I saw. Okay, don't forget your y equals. Don't throw an x in there if you've got theta. Do you need to use theta? No, you could have 3 pi x is fine. You can have a sign over here, that's fine. You could have a negative in front, that's fine. You just need to have it equal to something. You need to have a 3 pi in there, and you need to have +4 at the end. Smiley face is great. Mickey Mouse smiley face, even better. Okay, so the 2 skills we've done so far. Number 1, I gave you an equation and you told me the amplitude, the period, the center line, and the phase shift. We went backwards. I gave you characteristics and you gave me the equation. Third skill, backwards graphing. So we graphed all this stuff yesterday. Now we're going to go backwards. Here's a graph. What equation got you there? Here's a graph. What equation got you there? So this is backwards to what we did yesterday. However, I'm going to show you the tricks that's going to make it super easy. I'm going to give you the method first because I know you guys like that. Decide on a base graph and mark the endpoints. There are 4 base graphs you have to choose from, and I'll tell you in a second how to pick which one it is. If your graph starts at the origin, goes through a max, comes back to the y-axis, goes through a min, and comes back to the y-axis, what graph is that?
Sine.
That is a sine graph. Because sine, we know, goes 0, 1, 0, minus 1, 0. Well, sometimes what's going to happen is your base graph is going to go backwards. It's going to go down, and then it's going to go up. Well, that's related to a sine graph. What's the relationship? It's an inverse, not an inverse because it didn't flip the coordinates. It's a reflection. And it's a vertical reflection, so that's a negative sine graph. So there isn't really 4 different base graphs. There's really 2. It's just we can have the vertical reflection of sine and cos.
Can we have vertical reflection of tan?
We don't use tan as a base graph because it's not sinusoidal. Cos starts at the max, goes down to a min, ends at a max.
Usually looks like the letter B.
Kind of. So again, I just want to point out the difference between sine and cos. Cos starts in the middle, goes max, min, ends at the middle. This one starts and ends at the max. So starts at your high point, ends at your high point. What do you think the 4th possible base graph is? Starts at the min, goes up to a max, goes back down to a min. That's going to be the most common tomorrow, and you'll see why when we get there. And what's this base graph? It's minus cos of x, or cos of theta. It's just a vertical reflection of cos. Oh, I'll tell you. I'll show you in a second. So step number 1 is going to be pick your base graph. I'll show you in a second how you do that. Step number 2 is you need to find the center line, which is that d value. You need to find what's halfway between the graph. Well, all we're going to use is the formula for average. We're going to take what the max is. We're going to add it to the min, if I could spell min. And we're going to divide by 2. We're just averaging the high and low has to be halfway in between.
What does that say?
It says squiggly min, because I spelt it wrong and then crossed it out.
Was it max plus?
Plus min. Okay, I have to do it. I can't. Then we need to find that A, B, C, and D, and I actually start with D, because D is the center line, so you actually found it in step 2. So I always do D first, not D last. The amplitude is the distance from a max to a center line or the distance from a min to a center line. It doesn't matter because the center line is in the middle. So we physically just count on the graph. So distance from, and I'm going to put max slash min, it doesn't matter which one you use, to center line. And for the visual peeps, that's a vertical distance we're talking about. So we're just counting up or counting down, depending which way you want to go. The b value comes from 2 pi divided by the period. And the period is the width of the graph, so it's the distance from a max, to a min, from the center to the center. So I call it the distance from start point to end point. The distance from the start point to the end point. And for my visual peeps, that's always a horizontal distance, so we're counting side to side. And the phase shift we know is just the horizontal translation. It's how much we've shoved the graph over. So it's always the distance from 0 to your start point. Distance from 0 to the start point. And then step 4, we just put that A, B, C, D into the equation like we did in the previous examples. So until you see an example, some of this might be, and that's okay right now. Can I flip back? Because this is sinusoidal, we know it goes on and on and on forever and ever and ever. The problem is we have 2 mins and we have 2 maxes. So how do we know where to start the graph? It is completely up to you. I'm going to pick the max here and the max there, and I'm going to decide those are my endpoints. And so I'm just going to look at this highlighted section of the graph in between those 2 points. Why did I pick them? I don't know, because I wanted to. What base graph is that? So step 1 is mark your points and decide what's the base graph. Which base graph starts at the top and ends at the top. So I like to just jot down what base graph it is so that later I remember I'm doing a cos graph, not a sine graph. Then I do the d value because that is the center line. And that just comes from max plus min divided by 2. It's averaging the high and the low. We want to know what's exactly halfway in between. So my max value is -2. My min value is -4, and I want to divide them by 2. So -2 minus 4 is -6, and -6 divided by 2 is -3. I'm visual, so I like to draw it. If you're not visual, don't feel you have to. I just like to see it. And I like to know it runs exactly halfway through my graph. If you calculate it and you've drawn it and it doesn't run through the middle of your graph, you've done something wrong. It's not a distance, it's a placement on the graph. We want to know how much we've moved it down. What that tells us is we moved it down 3 units. Then I do the A value next because A depends on D. And the definition of A is the center line to the max or the center line to the min. It doesn't matter, they're both going to be the same distance. That's always going to be your amplitude. That's the second reason I like to draw it, because then I can see it visually to count. How many units between the center line to my max or the center line to the min? It's 1. Are we okay so far on D and A? Okay. Then I go to B, and B I know is 2 pi divided by the period. And the period is the distance from your start point to your end point. So it's the horizontal distance between your 2 points that you've marked. That's going to be the period. So to me, the first start point looks at 1.25. And the other point is 4.25. So if we subtract those, how many units between 1.25 and 4.25? 3. Okay, so period is from start point to end point wherever you put them. The C value is how much we've shoved this graph over, and it's always from the y-axis to the start point, because the start point is usually right on the y-axis. We want to know how much did we shove it over. Where is that value? 1.25. Okay. Oh, I'll just put a C here. It's always from the y-axis to your start point. Once we have those 4 values, we're good to go. We start with y equals. Amplitude comes first. I'm going to write the imaginary one just so when you look back you see that we talked about it, but I wouldn't actually write it in the question. Cos comes next because we already talked about this is a cos graph. The B value comes after the cos. I need to open a bracket because I have a C value. I need to pick a variable, theta or x, completely up to you. The C value has to be negative 1.25. Tell me why negative. Because it's to the right, so I need to change it to go into the equation. And my D value at the end is negative 3. There's working backwards. Imagine yesterday if I asked you to draw this. Right? Crazy. How would you do a horizontal compression of 2 pi over 3? Right? There it is. There's what it looks like. but the question says 2. The question doesn't just say 1. No, that would be too easy. I'm going to switch colors to do my second one. I'm starting all over. I'm going back to step 1. Step 1 is mark some endpoints. I'm going to pick this one that's right on the center line until it repeats back to the center line. Why did I pick that? Because it's a sine graph. Was that a knock on the door or no? Did I have to choose those points? Absolutely not. I could have gone min to min, which would have been a negative cos graph. I could have gone from this point over here to this middle point, would be a negative sine graph. It doesn't matter. You just need to pick 2 different starting and end points. So again, I like to remind myself that I'm dealing now with a sine graph because I'm starting at the center line, going up, going down, returning to the center line. D goes first because he's the center line. He's the max to the min divided by 2. What's the max? What's the min? -2, -4 divided by 2. Oh, he didn't change. Why didn't he change? So why is it exactly the same? It's the same graph. All I have done is change the endpoints. Did I move it up or down? No, so the d value will never change. It's always going to be identical no matter where you put your start and your endpoints. Amplitude is the distance from the center line to the max or center line to min. It's still going to be 1 because I didn't stretch this graph. I just moved where the endpoints are. The b value is going to be 2 pi divided by the period. Period is the distance from a start point to an end point. Start point to me looks like 0.5. Is that okay? And the end point looks like 3.5. So 0.5 to 3.5. 3 units. Oh, what do you see there? Didn't change because I didn't squish it horizontally. I didn't stretch it horizontally. What's the only value that's going to change when you write your second equation? C is the only value that will ever change. The base graph will change and C will change. A, B, and D will always be exactly the same. C value is just how much I shoved it over from the y-axis, and we said that was 0.5. So my second equation, y equals, again, I'm going to put that imaginary 1 just so when you look back, you know we talked about the amplitude being 1. This is a sine graph. The b is still 2 pi divided by 3. I need a bracket because I have a c value. I'm going to use the variable x for no reason other than theta is kind of annoying. Here I'm going to have negative 0.5. Why did it turn negative? Because I moved it to the right.
Negative 0.5.
And I have a value of negative 3. What do you notice between those 2 equations? Only C and the base graph have changed. Here's the problem with these questions is I could, in theory, extend this graph and I could write a bajillion different equations that represent this sinusoidal equation. They would always have the same A, they would always have the same B, they would always have the same D. The only thing that would change is the base graph and the B and the C value. So when you check your answer, you might have a completely different equation and that's okay. But what should match between you and the book? A, B, and D. Those have to be the same, otherwise you've made a mistake. If your C is different, that's okay. If you're not sure if it's correct, come and see me. So you might just want to make yourself a note. A and B and D are not going to change from 2 equations. A and B and D will always be the same. Again, I'll just repeat, because I've changed the endpoints, I didn't stretch it, I didn't compress it, I didn't move it up. All I did really was just change where the phase shift is. I'm just changing where I marked those points. Okay, thumbs. Good. And if you're here, I'm still okay with that. C, I thought we said was 0.5. That's okay? Write a cosine and a sine for the following function. So it wants the 2 again. You choose the endpoint. You can put them wherever you want. If you want a coast graph, it's either max to max or min to min, completely up to you. I always go for the obvious, and I pick the first max and the second max. But if you didn't want to do that, you could pick the second and the third. You could extend the graph and pick the fourth and the fifth. You could pick the 100th and the 101st. It's completely up to you as long as you go max to max for a coast graph. Whew. I always start with D because it's a center line. From there I get A, then I get my B, then I get my C. How do we find D, or the center line? Max plus min divided by 2. It's just the average between the high and the low. Where's the max? Where is the min? 9 plus 3 divided by 2. Again, I like to draw it because visually it tells me if it's correct, plus it's how I see the amplitude. If you're not visual, you might not need to draw it. It's completely up to you. How do I use that to get the A or the amplitude? Or to a min, completely your choice. It's going to be the same. What's that distance from halfway to the highest point? Oh, offer a 3, offer a 4. Right, it's got to be the center line divided by 2 because it's got to be halfway. B comes from 2 pi divided by the period. The period is the width of the graph, starting point to end point. So it looks like it starts at 1 and it ends at 4. 2 pi divided by 3. Coincidentally, the same as the last one. It won't always be. And for some reason, C is always the hardest. It's the one people ask me the most often. What does C represent? The phase shift, or the horizontal translation. So it's always the y-axis to the starting point. It's just how much we shoved it over. How many units? 1. Don't forget your y equals. Which of these letters comes first? And then? Before the B, I need something. I need cos. And then? Bracket or no bracket? Why minus? Okay, and at the very end? Such as? It's the problem is you've got to times it by theta, and you don't know what theta is. So no, you can't put the value in there. Negative cos, then you would go min to min, so your C value would be over here, which looks to be about 2. The A, the B, the D would all be the same. It's just the C value would be different, and you would have a negative out front. Okay, it asked for a sine graph, so let's go with a sine graph. I'm going to go, I don't know, from here to here. I don't like the negative side. I always kind of stay on the positive. I don't know.
How can you tell a graph is working out?
I can tell by the equation.
Oh, okay.
Yeah, you don't have to do anything on the graph. That's just there to help you if you need it. Okay, so that's a sine graph. How do I know it's a positive sine graph and not a negative sine graph? Goes up and then down. High five to you, Cole. You're totally getting this. Don't calculate D. Don't calculate A. Don't calculate B. Why? It's all the same. The only thing you need is the C value. You just need to know how much did we shove this over. It looks like 3 to me too. Agreed on 3? Okay, tell me the equation. This is like complicated math. Like this is 10% of the population can do this stuff, and you guys can do this stuff. Seriously, show this to an essentials kid, they'll cry. How are you feeling so far? One more, which I kind of feel like we'd be rushing if we did it, so I'd like to maybe do it first thing tomorrow. So tomorrow in the morning, I see you in the morning, right? I'm getting mixed up. I see you in the morning. We'll go over the last example. I'll give you back your quiz, and then we'll work on the homework from tonight in class, and then we'll go on to the applications in the afternoon. Does that sound okay? Say that all one more time. I said do the rest of the workbook. Every page. Well, I thought we'd talk tomorrow and see how we felt. Now, take the calendar that I gave you yesterday.
Oh, you're gonna change something.
It's golden colored. Rip it out, but it should be in your plastic sleeve, so you'll probably have to slide it out.
Rip it.
So, the administration decided to tell me today there's a university fair on the 5th and we've been invited. So instead of math class on the 5th, we're going to go to the university fair. But what does that mean to your calendar?
Everything's broken.
The whole thing will be off. So I'm going to print you a new one.
Can you rip it?
Yeah, you just I know.
How would you use it for recording?
Yeah, scrap paper, absolutely. But. So bad news is, yay, university fair. Good news. Bad news is I have to print a whole new calendar.
And no math.
Just period. We've been invited period 5. So you'll come to class that day. You'll do attendance. We'll go down. You'll get the free pens from everybody. We'll come back up.
Yeah,
That's how it works.
that's why I got my bone pen.
Maybe you can get another bone pen. I'm assuming you probably went last year as well. So boo for the calendar. Yay for university fair. That will be cool for you, Mr. Simon, the university fair. Since all the Canadian universities are represented. So you can talk to each and every one and find out what do I need for psychology? What do I do as an international student? How do I apply for scholarships?
Yeah,
If it's just for math.
this year he's
No,
just
every
slacking, man.
subject, every.
Notice that?
It's all grade 12s are going period 5.
So it's gonna be fun, probably. I like
the free
spending my last year for that thing. What was it?
It appears to still be recorded.
Thank you. Thank you, Andrew.